Okay, I think we can kick off with the webinar. So, good morning, everyone. Thank you for joining me for this webinar. I hope it's a good Friday. So, happy Friday to everyone. It's a short week here in South Africa. But yeah, today we're going to be looking at designing, scheduling, and simulating roads using Autodesk Civil 3D and Navisworks. It's a bit of a mouthful, but you'll see I've kind of condensed it into 3 steps, which you can follow, and we will get into the thick of things. In terms of who's presenting today, it's myself, Shuaib Yunus. I'm a BIM technical specialist in mining and civil infrastructure for Baker Baines, and I'm going to be taking you through the 3 steps that will make life much more easier for you and actually quite cooler to actually visualize your design in the construction phase. So let's have a look at the agenda for today. So as you can see on the right-hand side, it's just some snapshots I've taken from my model, the one on the top being Civil 3D, and then of course it's the construction program at the bottom that was linked into the timeliner in Navisworks. You can have a look at it just now, but in terms of the agenda, we're going to look at Civil 3D and Navisworks, exactly a quick intro rather, in terms of what it is and what it does, well, for both of them, and it'll give you a good idea in terms of how you could utilize the tools. And then I've just made like 2 snapshots in terms of the functionality overview, like the main points that stand out in the software, which is really cool. Thereafter, we're going to dive into a quick demonstration on the topic at hand. And then, of course, we're going to wrap things up and conclude. So a quick blitz, quick webinar, and I hope you enjoy. Okay, so let's look at Autodesk Civil 3D and Navisworks. Just a quick intro. So what is Autodesk Civil 3D? First of all, it's a 2D and 3D drafting and design tool. It's mostly used by civil engineers and surveyors as well as GIS technicians. So a lot of people don't know that Civil 3D has, I would say, 3 main interfaces built in, or actually 4. The first one being the civil interface, getting a bit tongue-tied here. Civil interface in terms of where you can do a lot of your civil applications, that being road design, platforms, survey, terrain, pipe sections, those type of things. Then you've got your general CAD, so your AutoCAD, your 2D interface for your quick 2D SketchUps. And of course, you've got the 3D modeling space where you could extrude, polysolids, those type of things. So if you have Civil 3D, you do not need AutoCAD. A lot of people make this mistake and they purchase AutoCAD separately. If you have Civil 3D, please don't do that. You already have access to the full AutoCAD, as well as there's a GIS, a Geographic Information System workspace, which is called Planning and Analysis. And that is typically or essentially Map 3D. So Map 3D is the GIS equivalent for Autodesk. So again, if you have Civil 3D, you do not need to go and purchase Map 3D separately, AutoCAD separately. It's all built into the software. So the software is very, very comprehensive. It's layered and there's a lot of detail in it, and it is very, very functional in terms of design. So as I've said, it's used for survey, roads, platforms, pipes, GIS applications. You can use it for rendering, drive-throughs, and so on. So it's very detailed. What makes it very powerful or very popular with the designers, including myself, is its dynamic and powerful interface. So a lot of old software, or well, I think they are actually upgrading them now, hopefully, fingers crossed, but there wasn't a dynamic component that was incorporated into the software, meaning that if you made any changes to a certain elevation or to a road alignment, if you increased the vertical alignment height or you decreased it, or horizontal alignments or platform elevations, for example, the cut and fill values wouldn't update, the long sections wouldn't update. You have to go and physically manually either redo it or alternatively manually refresh it. In this case, there's a dynamic interface that's built into the software, which makes design great, and it keeps your design up to scratch with any changes that you make. And of course, that makes it powerful. In terms of how it works in the BIM workflow, so building information modeling, it's critical because if you're doing a lot of civil engineering applications, and GIS and stuff like that, mapping, scans, that type of thing. It can fall from the conceptual or prelim stage right up to the construction documentation stage. So it's very versatile in terms of its use, and it's also very interoperable with a variety of software, including InfraWorks, which is amazing. If you haven't checked it, I've got my details at the end of the webinar. Please drop me an email. I can send you some info. It's really, really cool, the 3D rendering part of it. It's built on a gaming engine, so you can imagine the graphics are really cool. And of course, Revit, which is a very powerful tool for your build space. So it's a really, really good application to use, and it's critical in any design across the board, because civils literally is the base for all of the other disciplines to actually link in, because essentially you're generating the site and stuff like that. Okay, so in terms of the capabilities, there's a quick snapshot. Again, it's not all of them, but it's the ones that actually stand out to myself. The big one being, a lot of people always struggle with the survey and geolocation. You already got online maps that are built in using Bing imagery. Alternatively, you can use KMLs to actually set the locations, those type of things. Of course, you can do road corridor rendering, road design, drainage. You can make custom assemblies, platforms. Also, another one that's kind of hot topic at the moment is point cloud 3D scannings. You can actually import a 3D scan into here and you can actually work off it. It can be a bit messy depending on the size of your scan and how you maneuver it. But if you got your process in line, it's actually really, really awesome. Okay, so these are just some of them. And of course, GIS is a huge factor now with the connected BIM approach in design. So now that we have a kind of an idea of Civil 3D, let's go into Navisworks. Okay, so as you can see on the right hand side, there's 3 modules or 3 segments of Navisworks. I'm going to explain them, but normally when you have Navisworks managed, you automatically have access to Simulate and Freedom. But let me just show this to you. So in terms of Navisworks Simulate, it's a very basic, well, it is powerful, but it's not as good as Manage or as comprehensive, but it's used for communicating project details. You can go up to 5D, 4D, 5D analysis and simulation, but that's it. It's purely walkthroughs, fly-throughs, those type of things. In terms of Manage, this is the one that I use. It's very advanced in terms of the simulation. You can link in different disciplines. You got a lot of validation tools. You can control the outcomes, and the key thing is you can do clash detection. So if you are working on a build project, which is the most common case used, you can check your MEP, your structures, if they're clashing, if the duct's in the wrong place. And of course, in civils, your pipe networks, if they're in the wrong place or they're clashing with another pipe, those type of things. Very, very powerful, very comprehensive. And it helps you identify problems before you can even start hitting ground on the construction side. And of course, you've got Navisworks Freedom. So I think they named it Freedom because if you share the file with someone, they're actually free to view it. It's a free viewer, so they don't have to have the software on the machine. You share the file in an NWD or DWF format, and they can just install this free viewer and view the model on their PC. So you don't have to have a subscription to it. And then, of course, the reason why we use Navisworks is for all of those reasons above. I mean, you have greater coordination. You can simulate construction, which is really cool. And of course, you can integrate an entire project into one model. Okay, it does take a bit of work in terms of getting the positions right, getting everyone on team. I mean, the design part of it or the workflow is quite simple, but you need your team to be on your side here as well. So once you have that all set up and you can bring your model into correctly, you would see how really amazing models you can actually generate. Okay, and then there's just some of the capabilities in this snapshot. The key one is, of course, clash detections, model simulation. Again, you got reality capture capabilities like you're seeing here on the right-hand side. That's to do with point clouds. And of course, you got BIM coordination across different software, as well as BIM 360, which is a cloud integration application where you can document, share, and control your design processes in the cloud. It's really remarkable. And it's like push notifications to your phone. It's the best way to actually manage your drawing office. So if you're having problems with that, again, I'll have my details, we can have a chat. but we have really revolutionized a lot of industries here. It's not only civil, not only architecture, but it works across the board. Okay, if you don't know where you would find those software, okay, option one, which is the one not recommended, you can purchase them separately. So Navisworks Manage and AutoCAD Civil 3D, but it will work out more expensive than purchasing all these tools that you have on your screen right now. It's called the AEC Collection, so it's architecture, engineering, and construction. What Autodesk has done is they realized that designers need flexibility in terms of their applications, especially if you're working in a consortium. You need the right tools for a multidisciplinary project, and they kind of bundled it into this collection to help you out. So you've got all of these main software. I'm not going to really go through them. You can check them out online, or again, you can drop me a message. I can help you out there. But today, what we're going to do is we're going to be focusing on just those two there. So it's a Civil 3D. Civil 3D, we're going to be using it to do the geometric design, or rather taking the final design, reviewing it, and then inputting it into Navisworks. So we're not going to go into from generating a road from scratch. I have done webinars on that previously. If you check out our YouTube page and stuff, but again, I'll have that at the end of the webinar. Okay, so we're going to look at those two. And now that we have a good introduction of what we're going to do, let's jump into a quick demonstration. All right. So the first thing we're going to do is we're going to drive through the road. So a lot of people don't know that this is actually built into Civil 3D. I don't know why people don't use it. First of all, it makes our design look quite fun. I mean, especially in the civil industry, it's mostly 2D still, unfortunately, but there are 3D capabilities that people are either reluctant to use or just don't know how. But what I'm going to do now is I'm going to take the final design, which I'm happy with, and I'm going to review it by actually driving through it. So let's have a look. Okay, so here's my road. Okay, and if you want to go and have a look at Object Viewer, it's a 3D viewer that's built into Civil 3D. Let's pull this to the right a bit. The panning and stuff, you just have to get a little bit used to it, as you can see. But that's how it's currently looking. You can see the daylights, you can see the sidewalks, you can see the road, very visible, right? But what we're going to do is, now that we're happy with we got our final road elevation and stuff, I'm going to go to the top there and use the drive function, and I'm going to select my vertical alignments. And here we are. So we are in the 3D view. I've got it set to conceptual, as you can see there on the left. You've got a lot of different types of views that you can use, but conceptual kind of looks nice. And then, of course, you can either adjust the speed. So let's make it maybe 100, right? So 100 kilometers an hour. You can see the line of sight, eye, and stuff is set. And I click play, and that's literally your review of your road. It's really nice. You can also do this with rail. I've done it with the rail design as well. But can you see, you can actually preview your road. If something looks wrong here, you can actually pick it up before actually looking at the 2D or the lines that you have in your drawing. So it's a much more easy, quicker way. And of course, it is cooler. It's nice to have cool design. It makes people like the design more, because not all of us, or not all of your clients, are technical. They want to just see the finished product. Okay, so I've driven through my road. I'm happy with it. The next thing what we need to do is, now that we have the final road corridor model, we can extract solids from it. And what I've done is I've segmented it in conjunction with my construction program. What that means is I have decided that, or just for this case, I've said, you know what, I predict, or according to my construction schedule, that every week or two, I'm going to be finishing, let's say, 300 meters of road. All right, so I've broken up into that segment. So let's have a look. Okay, so there's my road. Right, so on the top, you can see there's as simple as extracting corridor solids. Simple as that, one-click functionality. And if you're familiar with Civil 3D, you should know what's a baseline. I'm going to split that into segments. So I'm going to add a region. And like I said, I'm using 300 meters. So I'm going to start at the beginning. And I'm going to just snap here to 300. So here we are. And you can see it picks up all the code sets that have been assigned to it. So your assemblies normally have code sets assigned. If you're not sure what that is, again, we can chat after this. Alternatively, you can just go to the help button on Civil 3D, or just go and look at your assembly. What an assembly is, if you're not familiar with Civil 3D, it's a cross section that's assigned to an alignment or to something to reference it off. So you can have different types of assemblies. It's not necessary to have a road cross section. You can have a retaining wall, you can have a trench, those type of things. So again, I've added another region, and then let's just do one more. Okay, so we're up to 600. I'm gonna snap there. Then I'm gonna go to 900. So again, this will be in conjunction with your road program. So whatever you have budgeted or projected for that week, you will work in that segment. So it's going to bring in a very simplified simulation to use for the timeline. And then of course, I'm going to click on my end chainage. And here we are. So you've got all the solids. You can see the colors assigned to it as well. You can go and customize it if you'd like. Alternatively, you can just leave it as a default, which I've done. But again, it's totally up to you in terms of how you would like to customize things. And then of course, once that's done, you can actually create the solids. So again, it's already referencing your sub-assembly name, which is not a problem, because it will pick it up from your code set aside to that baseline, right? So that all is set up correctly, okay? And then after that, what we're going to do is, if you'd like to format it, or you want to change the namings, you can actually route it in a different way, right? So like what I'm doing now. So if you can say maybe this region, and then you can use the shape code. Okay. So once you add that, it will actually pick up the changes. So from 0 to 300, 300 to 600, that type of thing. So that's what I've done with the layer name template. Again, it's not compulsory, but it actually is, I would say, clean design, if I could put it that way. So you don't get confused in terms of what region or what the software is actually referencing. Okay. All right. And now you can see it actually referenced it correctly. So I'm happy with that. And what I can do is just click next. And what we can do is you can either insert into the current drawing, or alternatively put it into a new drawing. Now, I normally prefer, well, most people actually prefer to use a new drawing. Okay. The reason being is that it makes your drawing much more easier to navigate. So you'll have your solids in a separate drawing, and then you'll have your original design in a separate one, or in the original drawing, and it'll make it much more easier to select. Okay, so I've saved it into a different drawing. Okay, you can see there we are. Just click open here, and there it is. Okay, so that's your solids extracted. Okay, so just to recap what we did, we use the extract solid function by clicking on the corridor. As you can see, my segments are actually separated correctly. So each thing is on its own element or own component. And if I had to change the view, here we are. Okay, so that's how it comes in with the same colors that were referenced previously. All right, so you can just take a quick toggle around, have a look at it. And if you just want to see the layers as well, or the sub-assembly layers, if you click on it, you can see that they are all solid components. If I zoom in a bit, you can see here that each layer is its own element component. So that was step 2. The last step that we're actually going to be doing now is, now we're going to take that construction model program and link it to our model, and use the timeline function to actually simulate or look at the progress of the road versus the timeline attached. So the construction program is a basic Excel sheet where start to finish, you just assign your time there, and it will literally read it correctly. Okay, so let's have a look at that. So first we're going to import this into Navisworks. If you haven't seen Navisworks, this is literally how the interface looks. We're going to just import this in or append it in. So that's the solids that we're going to extract, and we extracted already, and we're going to import it in. Okay, if you import it and you don't see it, just zoom extends to zoom all. It is there, and here we are, right? So the same thing that we've seen, you can see that the components are still singular, or right? So you can select each and every component individually, all right? And then from there, what we can do is you can actually navigate it, because people like to check it sometimes in terms of if any detail is missing, which is I haven't come across any time before. But what we can do is let's just toggle it in a longer view, as you're gonna see just now, right? So again, that's how roads come in with the components. You will have to get used to the pivot just a little bit because it's very sensitive, as you can see on my screen. Just trying to position it correctly. And you can see I've selected the timeline on the top. So this is how it looks. That snapshot that I had in the initial slide. What we're going to do is we're going to link this model with a task, okay? So as you can see, we've added a task. Currently, there's no data that's been populated in here, but I've got an Excel sheet with the regions attached to it. So again, you'll have this already, whether you did it in MS Projects or a basic Excel sheet, you will have the start and finish times for your actual topic. But here I'm specifically focusing on the design aspect or the construction of the road itself, or in singularly, right? So what we're going to do is we're going to import that CSV or Excel sheet, whatever you use. You can see Microsoft Projects is on there. Primavera, if you use that, you can use that as well. It's compatible. Okay, so whatever you're using, by all means, import it. So I've got it. I've called it timeline. I'm going to import that in. As you can see, once I do import that, it'll just take a little time to load. All right, so we can rebuild it. Just close that, and here we are. Right, so we've got the data. You can see I've put in my times there. I've got 9 a.m. and 9 to 5, so your site times. Normally in South Africa, I think we start a bit much more earlier here, but I've just used 9, right? But here we are. We've got our details locked in. We've got our regions locked in. And what we're going to do is we're going to simulate this now in conjunction with what we put in. So it's going to take the data that we've used now, and we're going to apply it to the constraint. So you can see my 300 meters there, or region 0 to 300 currently on the screen. And what we're going to do is now we're going to simulate it by simply clicking play and have a look on the top and bottom. You can see the road get constructed as the date is being populated at the bottom, right? And you can see even on the top right, top left-hand side, it gives you the day, the time, the week. So it's currently in week 2, and it actually progresses as you're going, which is quite awesome. So if I had to click pause here, or if I had to stop and say, you know what, after 3 weeks, how far would be in terms of construction, you'll be able to see that you'll be at chainage, so, or region 2 or region 3. It's a really handy tool. Again, this is the basic part of Navisworks. You can go in much more detail than this, but I thought I'll just start off on the basics. And as the webinars progress over time, I'll get into much more details of these things, right? So that's about it. I mean, let's more or less wrap things up. So again, what I've showed you first is use the drive-through function for review in Civil 3D, okay? It's a really cool tool to use, and it's very visual, so you can pick up if there's any funny kinks in your road, or if something doesn't tie up, you will actually see it. You can actually set it to a wireframe, so you can even check the triangulation. Alternatively, you can have it in conceptual view like I have on the right hand side. Then after that, once you have your construction program, make sure that you export your solids according to what you have there. So if you, like I said, I've used regions of 300 meters. If you are working in 100-meter increments, it will be in 100 increments. So as simple as that. Once you have that, you use the timeliner function, you import the solids into Navisworks, you link in or you add your data for your construction sheet or construction program, and then you just click play on your simulator. Okay, so that's about it. If you do have any questions, please email me, because I like to respond to each and everyone individually, and I could maybe understand your question much better. If you want to connect, that's our handles at Baker Baines. On the top, you can simply just Google it. It'll pop up. We have a YouTube channel, so this will automatically be posted on there. I'm also going to start posting my previous webinars on LinkedIn as articles. So because I've got a lot of you on LinkedIn and we communicate there, so you will have access to it. So just give me a bit of time, just a bit of catch up what to do there. But yeah, and you can also follow me. Please feel free. If you come across anything really cool, anything informative, you have any questions, drop me a mail, drop me a LinkedIn. I really like interacting with the users. And of course, here at Baker Baines, we have webinars every month. Mine is normally at this time slot on a Friday. Sometimes I'll have two a month depending on what topics are hot in industry or the things that we receive. But there are a lot of webinars across different disciplines. So I'm in mining and civil infrastructure. We've got architecture locked down. We've got mechanical process plant. We got mining. So we literally cater for each and every main segment in design. So if you are interested or you're working on multidisciplinary projects or team members, please either subscribe to my LinkedIn. Alternatively, you can subscribe to our homepage. Either way, but I post most of my content on there. So I hope you've enjoyed this webinar. I hope it was informative to actually see what you can do with these tools. They're really powerful. And trust me, when you're using or working on a very complex project, visual representation is the key to making informed decisions. So yeah, thank you very much for joining me. Happy Friday. I hope you have a really awesome day, evening, and a weekend. And yeah, I'll catch you for the next one. So thank you very much.